The Sun, general. Diameter of 1.4 million kilometers, 150 million kilometers from Earth. It is a rotating gas sphere, 75% hydrogen, 25% helium. Surface, or photosphere, temperature is 5,800 Kelvin. The chromosphere, sphere of colour, and the corona, crown, make up the Sun's atmosphere. The chromosphere is 2,000 kilometers thick. The corona has a temperature of about 2 million Kelvin. The Sun's energy source. Nuclear fusion reactions in the central core. Temperature in core around 15 million Kelvin. Hydrogen nuclei, protons, fuse together to make helium nuclei. This process is called the proton-to-proton chain. As part of this process, matter is converted into energy in Einstein's E equals mc squared. Energy equals matter times speed of light squared. The Sun loses over 4 million tons of matter each second. Some of the heat generated by the proton-to-proton chain maintains the high temperature of the core. The rest is radiated out into space. Safely observing the Sun. By far the safest method is to use an indirect projection using a pinhole camera, binoculars or telescope to focus an enlarged image onto a screen. Use a card or wooden baffle to create a dark shadow on the projection screen. Also, the objective lens should be covered with black card to reduce light entering the telescope. Alternatively, you can fit a high-quality H-alpha or mylar filter. This is not recommended for beginners for safety reasons. Never observe the Sun directly with the naked eye, camera, or other optical device. Sunspots. They are about the size of the Earth and are cooler areas of the photosphere. They correspond to strong localized magnetic fields and usually occur in pairs or in groups of opposite magnetic polarity. Typical structure. An umbra, central darker region, 2000 kelvins cooler than the photosphere, and a penumbra, less dark surrounding area, about 200 kelvins cooler than the photosphere. Sunspot movement. Rotation period for sunspots, 25 days at equator, 36 days at poles. This shows that the Sun does not rotate as a solid body. They can last from a few days to several weeks, and the number follows a regular 11-year pattern called the solar cycle, during which it reaches a maximum, then falls again. Positions can be plotted on a butterfly diagram, plotting their latitude against time. The cycle begins with a relatively small number of sunspots, between 35 degrees and 40 degrees north and south of the equator. End at latitudes between 5 degrees and 10 degrees, i.e. near the solar equator. The solar wind. It's a steady stream of charged particles, mainly protons and electrons. It flows outwards in all directions from the corona at the speed of 400 kilometers per second, slow solar wind. The high temperature of the corona gives the particles the energy to escape the Sun's gravity. The fast solar wind travels at 850 kilometers per second and originates from coronal holes near the poles, which allow charged particles to escape more easily. The appearance of the Sun at different wavelengths. The Sun can be studied at different wavelengths of the electromagnetic spectrum: visible, X-ray, H-alpha light, 656 nanometers, emitted by hydrogen gas. Fitting a H-alpha filter to a telescope allows features such as prominences and filaments to be observed more clearly. Also, solar flares, sunspots, and the chromosphere. Solar word definitions. Prominences. Huge clouds of cooler gas in the Sun's atmosphere. Filaments. The same, but appear as a dark silhouette against the brighter photosphere. And solar flares. Sudden releases of energy.